All right, there we go. I wasn't sure if I had to push a button or not. Well, welcome. I'm glad you're here. So we're going to talk about serverless today, because who needs servers anyways, right? So just by way of quick introduction, my name is Justin Lee, and I work at Red Hat at the moment, and I work on the serverless tech team. It's a research and development team. We're trying to build a serverless stack on top of OpenShift. Is anyone familiar with OpenShift? It's kind of our Kubernetes distribution. You can use it for multiple cloud provider clusters, basically. So you can cluster across, on-premise, Google Cloud, Microsoft Azure, whatever you like. You can run it all on OpenShift, and it just seamlessly interoperates. So we're trying to build serverless stuff on top of that, is what my current role is. I am a Java champion, and I've been a Java developer since '96. I was talking to someone this morning, and I apparently did not look to be my 44 years of age, but I am that old. I've been doing Java for a long, long time. I'm also a Kotlin fanatic, so this is sort of interesting detail, I suppose, but primarily, I just want to say, and this probably for this room is not such a big deal. I'm a Java guy, so a lot of the conversations, a lot of influences in what I have to say will be Java influenced, but one of the perks of serverless and functions as a service is you don't have to use Java. You could use Rust, you can use Go, you can use Python, JavaScript, whatever. So, but anyways, so that's my bias. So I'm an open source contributor. I actually have the benefit right now of working for a company whose, my manager keeps telling me, default to open. Everything that we do is in the open, pretty much, at least beyond certain internal, let's investigate this, but once we decide to do it, everything I write is up on GitHub, for example, which is lovely, because I can show whatever code I like, and you're not going to steal our secrets, because it's already on GitHub anyways. So, and I also, on a more personal note, happen to be a terrible Swedish speaker. I lived in Sweden for a while, just long enough to sort of learn the language, and then I had to move back to New York City. So if you speak Swedish, I sort of do. So anyways, so that's a little context of who I am and why my opinion might matter. So, but let's move on. So this is the serverless data center of the future. It's beautiful. It's all white and clean. Very easy to maintain. No cables to worry about. It's awesome. But of course, serverless doesn't really mean that, although it's fun to joke about. So yes, there are servers. You have physical boxes somewhere. Even on Amazon, Amazon has 1 billion servers somewhere, right? We just don't have to deal with them. So there are servers, there are processes, there's things actually going on, actual computers, but the platform manages it all for you. So in terms of what you have to worry about, servers are not really one of them, for the most part. So that's where the serverless term comes from, even though it gets a little bit abused. I saw a great comparison, like Wi-Fi. It's like wireless internet, and then you go look at the box, and it turns out there's like 100 different wires inside the box. So it's wireless, but eventually there are wires somewhere down the stream. So before we go off into the standard definitions, has anyone started taking a look at serverless and kind of exploring maybe what's going on? Oh, good. This would be a good talk for you then. Because it's a new field, and it's so new that even people like myself who are building on it, there's still a lot of questions that we haven't resolved yet. The biggest which for you guys is why would I use it? Which is a fair question. So we're going to try and answer some of that today. So if you look at the Wikipedia definition, it's a computing execution model. The cloud provider dynamically manages the allocation of resources, and pricing is based on the usage. It's a lot of words. Martin Fowler has one that's a little bit simpler. It says applications that significantly or fully depend on third-party applications, and basically it outsources a lot of its computing needs. Anyone ever heard the term backend as a service? Database as a service? It's the same sort of notion where I need a database, but I don't want to manage it, so I'm just going to let some cloud provider do it. Serverless just kind of codifies that into a more constrained notion. He also has, this is the same notion, where you write some application logic, but it runs in a stateless container. There's no state in a function. It may or may not, your function may or may not stick around for more than a handful of seconds. Who knows? So my colleague tried to distill this into something a little bit more meaningful, because it's a lot of words to remember. So it's a computing execution model that depends on services to manage server-side logic and state, but the business logic itself runs in stateless, event-triggered, typically Linux containers. It doesn't have to be Linux, but if you've ever done much with Docker or Kubernetes, it seems like everything is built on some version of Linux, because why build a Docker image with Windows in it? It's just weird. So let's talk about a scenario. So we have a developer with a new assignment. We're going to build a product catalog, and it's going to do a couple of things. It's going to store new products whenever a merchant, one of our customers, has a new product to sell. They need to add it to their catalog. And then that catalog will also potentially have like images attached to it, right? Like if you want to buy like a car or whatever, like you'd like to see what it looks like before you show up and find out that it's like the Flintstone mobile. You guys remember the Flintstones with the big rocks? Not the kind of car you want to drive home. So here's what it knows. The developer knows about microservices, understands containers. Who knows what Kubernetes is? Okay, more of you, good. So yeah, you know that Kubernetes helps, and I love the quotes there, because when you work with Kubernetes, it helps after a point, but getting to where it's actually useful can be a little complicated sometimes. So in this case, the developer loves Python and JavaScript, but the idea is just she wants to start small on a small application and build an evolutionary architecture that can grow as she kind of figures out what are the actual requirements, what it needs to do. So it needs to support incremental changes and exploratory development, because one of the nice things about development is you can build all this stuff, and if you don't like it, you can just delete it, right? So you need a system that works for that and helps enable that. So what does she not know from day one? How many users? If you've ever put something on the web, that's always the big concern, like what sort of scale do I need to support? What's the storage of this system? How much disk space or whatever? What's the size of the whole system? How many machines? How many web servers? How many database servers? Kind of all these questions you'd have when building a cluster. Which database to use? I used to work for MongoDB, so I have a bias toward that particular one. I like PostgreSQL as well, and there's Couch and Redis, and there's all these great databases. Like, which one do I want to use? I don't know, not yet. So, and of course, how to build an evolutionary architecture. That's kind of the prize there. So then the questions like how and when to resize the pictures when they get uploaded, how to send notifications when something happens. And then there's like bigger questions, like what about security? Access to the system. What about encryption of your data on the disk? And then kind of longer term questions of monitoring, patching, how do you upgrade, how do you fix bugs, how do you respond to errors, and how do you scale, of course, is the big question we're all trying to answer. And then the biggest one of them all is how much is this all going to cost me? Because it's not terribly difficult to spin up some EC2 instances on Amazon, do your work, it's like, that was awesome. And then a month later, you get a bill for thousands of dollars because you forgot to turn stuff off, right? And now nobody's happy. So if we look at a breakdown of what this looks like, some of these concerns are FAS, or functions as a service. Inside Red Hat especially, and we're not alone in this, we try to make the distinction between FAS and serverless. So what I want to do here is kind of outline what the difference is, because sometimes the terms are used interchangeably. And that's mostly fine, but sometimes the words have a little bit of meaning and connotation behind them that might give more weight to them. So the FAS concerns are, how many users, also down here is scale, like how are we going to scale this? How and when to resize the picture, that's also kind of a FAS, it's like a very kind of localized, discrete unit of work. Then questions of monitoring, patching, error handling, those are all kind of function-related issues. Like how do I monitor that image resizing function? How do I patch it? How do I respond to errors, bad file formats, or whatever? So those tend to be where we would lump the FAS into the world. As for serverless, it's kind of a handful of these others. And you start looking at the wider system, right? Like which database, what's the size, like how many servers do we need to requisition? How to send user notifications, so how to interact with both the user and other parts of the system, for example. And of course, cost falls under serverless, because it's a little bit of a more, a broader system-level concern than a specific function as such. So the way we like to break it down is this. So FAS, in our minds, is pretty much your function. Now, you may have 1,000 functions in your system, but handling those is kind of the FAS into the world, whereas the larger things, the database, the storage, all the events, the broader API that you might expose to your end users, for example, those tend to be more serverless-oriented concerns in our mind, because they tend to deal more with managing your system as a whole as like one congruous application, as opposed to 1,000 different little tiny functions, right? So it's just kind of a question of how you view it. So if you look at the architectural evolution over the last few years, you have, we start off with services, just large, monolithic, any Java EE developers? There's a few of you will still admit it. It's fine. I used to work on the EE container, so. But you'd have these large WAR files and you deploy them, right? And it was just a huge block of code, especially if you're deploying an EAR file. We're talking like tens of megabytes, hundreds of megabytes, and every time you upload it, every time it's just the whole file, right? It made deployment very complicated. Then we moved to microservices with the rise of REST and gRPC and the things like. So they become a lot more streamlined, right? You started segmenting your application vertically. So here's payment, here's images uploading, here's account management. All these separate concerns happened in microservices, and then those can be upgraded and scaled and whatever independently. And that was awesome. But you still have a number of things all bundled together. And that's where functions come in. So now we can take our microservice and take the image manipulation. It takes longer to manipulate an image, to resize it to, I used to work at a web hosting service, and we would take an image and we'd rescale it to 8 different sizes, right? So whenever, depending on how you laid out your page, you might want an image or you might want an image. But then we would be, depending on the HTML layout around it, we could get you the image that was closest to the size that you wanted, so we're transmitting fewer bytes over the wire, right? Now, if you wanted the big one, we'll send you the big one. But if your block is this big and we sent you this image, now suddenly we sent you, megabytes more than you really wanted. But anyways, all that to say is that manipulation takes way longer than just serving it, right? So maybe you want to be able to scale out your image manipulation, but your image serving doesn't really need that much compute power behind it, right? Really, it's reading bytes off a disk, sending it down the wire. Not a lot of scale issues. So that's where you can start thinking about in terms of functions. So when we look at the scale here, on the one end, we had control over everything. We decided what hardware was, how much RAM, how much disk space, everything. But it was also terribly complex because we all managed all those bits together, and it was very hard to separate those concerns. And as we move more into functions, productivity goes up because now we can do a lot more kind of targeted work. We can ignore parts of the system that are working and just focus on the interesting bits. But you also lose a little bit of control because, as we'll look at later in a very brief demo, you deploy a function up to the system, and that's really all you do. In our case, we'll see like a jar file. You can say, go deploy this jar file, call it this, and expose it as a web function or not. And that's really, for the most part, all you can tell how to do a function. And the rest of it, the serverless bit handles for you. So I have some other slides, but since I have a constrained chunk of time, what I want to do a very quick demo just to kind of show you what it might look like. Oh, that was really loud. And then what I'd like to do is I can come back to the slides and I can answer questions. I tend to favor more kind of an interactive style, and I don't know how much you guys are into that sort of thing, but I like questions midstream. So if you have them, throw them out there and I'll try to answer them. But let's try and do a demo, and let's see if I can get this screen sharing thing to not destroy everything. Can you guys read that? Maybe. Oh, no, I'm going to turn off screen mirroring because I can't see that tiny guy. All right, there should be a whole bunch of stuff. All right, out of the way. How readable is that up there? Can everyone see it? Okay. I always get tripped up by fonts on this sort of thing. So what we want to do, for this particular demo, I'm going to use Apache OpenWhisk. I think there was a talk earlier on, was it Project Riff included? There was a serverless talk earlier, and I think he was doing Riff and Spring Boot. We're going to do OpenWhisk, which is from the Apache project. It's one of the projects that we're looking at inside Red Hat. We are contributors along with Adobe and IBM, especially. So this is the bulk of mine. So what we're going to do here is a little demo showing if you just have like a single function, those are less interesting sometimes than it could be. So we're going to do a slightly more interesting demo where we're going to take a string, we're going to split it, and we're going to uppercase it and sort it, right? Mainly to show a few things. We're going to do one step in Java, one step in Python, and one step in JavaScript. And the system is just going to work. We don't need to worry about the other functions. We don't even need to care that they're not in, say, Python. I'm assuming mostly Java people here, right? Yeah. Python, JavaScript. He looked, don't be proud. Python's okay. He was like, I don't know. I'm sorry, JavaScript. Okay. How many Go people? Nice and proud in the back. I like it. Anyways, I'm a Java guy. I write mostly Go code and YAML these days, so I'm learning to love Go. So let's take a look at the first function. And it resized, and of course, now looks terrible. But we're going to get this figured out. So the nice thing about this serverless development, that should be readable, I hope, in the back. Yeah? No one's complaining. So the nice thing about these functions is that you can actually develop them in isolation and test them locally. If you do a lot of things inside of a web container or whatever, sometimes there's some extra infrastructure that you have to test it. Not always, but sometimes that can be a little problematic. But the nice thing about these functions is they're very discrete units of work, which makes them easy to isolate and test. So in this case, we're just going to take we're going to take a comma delimited string. I should rewrite this in Kotlin because the Java code is a bit verbose. But it's going to take a string, it's going to split it on the comma, and what's going to come out of this is a JSON array. So the inputs and outputs of most of these functions are going to be JSON-oriented. There are a number of serverless frameworks out there. Most of them tend to work with JSON. A few of them offer you some other options, but JSON seems to be the default choice. So if we take a look at step one, which I really can't read on this screen. So the first step that we do is we're going to create what's called a sequence. And this just tells OpenWhisk that we're going to create a number of functions and we're going to sequence them together, right? Mostly just housekeeping in that step. But the nice part is now we're going to build our splitter, and we're just using Maven. And I did -Q because Maven is very chatty. So as you can see here, it built. It looks just like every other Java thing you've ever done. Runs test, the whole thing, right? And then the next step is there's a command called whisk that you interact with OpenWhisk for. And the details are not entirely important, but so here we're telling it to update the action. We're going to call it splitter, but it's in the sequence, which was aptly named. We're going to tell it what jar it is, and some of that might get lost in the scroll up there. And then we just tell it what our jar is and what our main function is. So as a developer, that's all you have to concern yourself with at this point, right? There was no allocation. How much memory do you need? How much disk space? Even what JVM, you'll notice we didn't really care about up there, because in the case of OpenWhisk, there's a Java runtime, and I think it's Java 8. And there are a number of different runtimes you can use, and if you really needed, say, Java 11 because it's finally out, you can create an action runtime and put it up on there, then you just have to specify which runtime you want to use. Right now in OpenWhisk, there is, I think, Python 2 and 3, JavaScript, Java. You can actually do a Docker image as well, but we're not going to cover that. So that's our function, and if we wanted to see it run, it looks like this. So we're going to execute that command using the whisk command again, and we're going to pass it in a string. That feels small. Is that small on the screen to you guys? Oh, that's nice and big. Is that better? So you can see it there in the middle. We're just passing it's a key value pair text. We're going to give it a string. It's conveniently in reverse English alphabetical order. And then we're going to save off the results because we're going to reuse it. And that's our Java function. As you can see, it came back really, really quickly. Now the others are, the code themselves are not as interesting as you might think. For example, I'm going to blaze through this so we can see. I want to get to questions as well. Sorters in an uppercase. All right. Also not readable. Come on. No, wait. I have them over here. So the Python version, so the sorter, for all you Python people, I'm sure that makes some of you twitch because it's not terribly complicated or probably idiomatic Python code, but it works. It takes in a JavaScript document, and we're going to get out the result, and we're just going to sort it. Again, not terribly complicated. And then the uppercase version is going to be very similar. We're going to take the same thing, and we're just going to go through and uppercase each one of them, right? So, like I said, this is not terribly exotic code, but it's mostly designed to be illustrative rather than anything else. So I'm just going to blast through some of this so we can see it in action. So we're going to run our sorter. So you can see we invoke. I didn't do the create because it's already up there. So we're going to invoke the sort. As you can see now, it's in alphabetical order. And if we were to invoke the last bit, we can see that it is also, it's now uppercased, right? Now where that starts to get useful is you can do this. We're going to create the new sequence, and we're going to give it just the list of the 3 functions. And then the system itself will then handle when we invoke our function. We just tell it invoke strings, this is the sequence we just created, and then it ran it through each of the 3 steps for us. So we didn't have to worry about in our split function, we need to then call out to this other function to pass the data along. We didn't have to worry about where the data was coming from. For each function, we could just worry about just that one function with the terribly complicated task of sorting a string, sorting an array, right? That's all we had to worry about. That's all we have to test for, right? So in this case, the system then let us chain them together, and then we can create workflows that way and string together sequences without having to be overly concerned at the function level what comes next or before, right? And this also lets us then combine them in workflows externally without getting terribly lost in the weeds. So I have a little over 6 minutes, 5 minutes. I wanted to go over some final slides just very quickly, and then I'm gonna do questions because I like questions. I don't want to mirror. Let's see how badly this breaks. It sort of worked. And we're back. But I'm going to skip ahead because because the big question on everyone's mind is, what would you use this for, right? It just seems like overly complicated for what we want to do, right? So let's talk about some uses. The big one is auto-scaling. Like I say, new user sign up, Christmas comes around or whatever holiday comes around, and suddenly you have 1 billion new people signing up for your website, but you didn't plan for that, right? And then your servers crash, everyone's awake at 3 in the morning trying to spin up new servers. the serverless system would auto-scale those functions for you. It has systems in place to monitor like what the load is, and if need be, it'll scale up new instances and then load balance across those instances. So it might be that you can get by with just one instance of your function running because it's stateless, right? So you can, as long as the system it's running on handles the load, you can just send 1,000 concurrent requests or 10,000 or whatever, and it's fine. But if it starts to lag behind, if performance starts to lag or that server goes down, the serverless system can spin up as many instances needed, and you don't have to worry about it. So, for example, we talked about media manipulation, event processing. If you're watching Twitter and you're trying to, track current trends on whatever, you can have events coming in and trigger those functions as well. Payment processing, large-scale computations, and this is one of my favorite uses. I have some friends who they are contractors for NASA, and they're working on putting things in orbit around the moon, around Jupiter's moons, around the Lagrange 2 point. If any of you are space nerds, it's this 5 points of equilibrium of gravitational pull between the Earth and, say, the sun. Anyways, so they're doing these computations where they're trying to compute orbits, like when should we launch, when should we thrust, when should we course correct, and then trying to figure out what are the best time to do that. So they do what are called Monte Carlo simulations, where they just throw out a whole bunch of functions, see what the numbers come back, and then pick the best one, right? So for them, this would be really useful because they could fire off, if it's a 1 million case scenario, they could fire off that compute function off into serverless thing. The serverless system would scale out their functions, perform all this math concurrently, and you get back an answer, as opposed to sitting on your laptop or whatever, waiting for a million different computations to finish. So for things like this, it's great. One of the things that is coming up in some of the discussions we were having with Google is the concept of continuous integration, continuous deployment, which is fascinating because you commit to GitHub, right? Fires off a webhook, and then perhaps maybe your function is running your build and running tests, right? But if you have a large compute matrix, when I worked at MongoDB, we would submit a change, and we'd have to test against multiple versions of the database, multiple versions of the JVM, multiple versions of the operating system, and this and that. And one commit might trigger 380 jobs, which took forever, right, to churn through. So it's an interesting option to use those as functions and span those out across a serverless cluster as well, which, it might be a terrible idea, but I like taking interesting ideas and abusing them. So let's cover some obvious questions. One of the ones as a Java guy, like, can I use frameworks? Like as Java people, we like our frameworks. Why rewrite code when you can just borrow one and use it, right? The answer is yes. If you look at Pivotal stuff with Spring, they have a project called Project Riff, which is their serverless implementation. Most of their examples run on Spring Boot. So it's doable, but you just have to be concerned about startup time and memory usage, which may or may not be a problem. API discovery and management. If you have 1,000 functions, knowing what's out there, as Java people, we're used to having Javadoc, right? You can see what every class is and every method is in the system because it's just there. So there's going to have to be some new tools around how to document what your serverless system looks like. Versioning and A/B testing. Are you familiar with A/B testing? You put out a new version of your system, but you only route like 10% of your traffic to it because what if it breaks? Or what if it renders really ugly? You don't want everyone to be mad, just 10% of your users. And then if it's really that terrible, you can take down version B and everyone else just goes back to version A. If it's great, then you can start routing more and more traffic over to B and then deep provision A. So tools like that, they exist for microservices, so I think adapting them to functions is not going to be terribly difficult. It's just a little bit of extra work to do. Rollbacks of old versions, of course, is very important. Monitoring, knowing when a function goes down would be nice to know. The serverless system will restart it for you, but it's nice to know that it went down so you can figure out why. Tracing requests and logging through your system. These are all distributed function points, right, that may only last for 3 seconds. So if you're logging to standard out or to syslog, that particular instance may not be there when you come back in an hour. So some sort of distributed centralized logging needs to be put in place, and there are systems that are now vying for that, but no one has really settled on like a clear winner. So just real quickly, some future considerations. I'm a Java guy, and Java gets a bad rap in the serverless space because the JVM takes so long to start up, right? And we saw in 2 talks ago, GraalVM is very interesting to be able to emit out native binaries of your Java code. His Spring Boot app started in 6 milliseconds, which was awesome, as opposed to the 1.2 seconds. Some people don't like that. Knative out of Google kind of disrupted the whole serverless space earlier this year, and so we're still trying to figure out how to make all that work. And this could be really great, and it's probably the future. And also, at some point, if you go look for serverless frameworks, there's like easily a dozen of them, depending on what your language or your preferences are. At some point, some of those are going to die, and there's going to be 2, 3, 4 major winners. And the big question is, which horse do you bet on, and you hope it's the right one. So those are some of the primary concerns that I see going forward. And of course, I want to get Kotlin in the mix there as well, because I prefer to write Kotlin these days. But anyways, so I'm technically in the red now at 32 minutes. Do we have time for questions? 1 or 2 questions. Okay, I'm sorry, I didn't mean to go long.
So thank you, and 1 question, and other questions, please ask on the party, during the party. So the question is, when you shouldn't go serverless?
When shouldn't you go serverless? Well, I like to play with new things, but I also believe like if you have a lot of money riding on it, like if you don't know that you should go serverless, I wouldn't rush into it right now, especially since like with the Rust web services, there's still a lot of kind of questions and things being ironed out, a lot of questions being answered. And so if you're not comfortable with that risk, then I wouldn't necessarily go right now. But if you have a whole lot of really involved interactions inside your code, that may not be the best fit for a function, because your function should tend to be like a very constrained set of functionality. But if you call a function or a method in your REST endpoint that calls over here and does this and is bouncing around your system before returning, a minute and a half later, might not be a good fit for serverless, because you'll want something a little bit more robust involved.
Okay, thank you. And all our questions, please ask after.
I'm happy to chat about whatever. So thank you.